negative x.
That is the derivative of number 12.
Yes.
Negative e to the negative x.
Yes.
That's as far as I got.
And how do I find a derivative?
That is
That is the derivative.
I mean, what do I do with it?
Set it equal to 0?
Yeah, see, okay, I figured that you did that, but how do you
set that equal to 0? What do you do after you set equal to 0? Just no answer.
Multiply by, you take the square root.
Well, guys,
Just put a negative on
guys, you can't just yell things at me.
That's not right.
I know that's what you've been trying to do. I realize that's what you've been trying to do.
She can hear it.
Hey, I want you to buy a
But that,
the opposite of E is ln times genus.
that is not the derivative
E
to 14. That is not the derivative to 14.
We're doing 12.
Oh, 12, sorry.
I did the exact
Okay. There are no, it's never equal to 0. Because a number to a power can never equal 0.
So none.
Ever.
Wait, what?
A number to a power can never equal 0.
So then
Ever.
plug in the
So all you have to do is f of negative 1 and f of 1,
That's what I did.
and you'll find a min and max.
Oh, we have 0.71 interval. Oh my gosh.
Hey, Harris, remember when I said that we were supposed to do that?
Yeah, I did.
You were like, oh, we're not doing that.
Yeah,
Stupid.
This is all your fault. Wait, hold
Everything's
on.
my fault now.
Wait.
Yeah,
Wait. Why can that not equal 0? If x was 0, then it would be 0.
Let me do 1.
No, wouldn't it be 1?
Negative 0.367.
Anything to the 0 power is 1.
Oh.
Ah.
So, where are we going now?
Oh, so
Whoa. 16.
What?
So is 14 the same thing?
Well, what's the derivative of 14?
To the negative x squared
Negative.
minus
Negative 2 e to the negative x squared.
14 is negative e to the negative x squared, right?
Yeah.
Times what?
2.
No.
What?
I was on Harris.
Oh.
Negative 2x minus 3. Or to the negative 3.
Negative
What?
Wait a
I
minute.
got negative 2e to the negative x. That's what I got.
Why do we have a negative here?
I don't know.
I don't know.
Should be.
I don't know.
I thought it was negative 2e to the negative x squared.
Isn't it this times negative?
2x.
2x.
Okay, so negative 2x e to the negative x squared.
I like that better.
I like that better.
That's what I got.
But
So we can set this one.
I'm going to say it again. You guys have to you can't just yell things at me while I'm trying to do a derivative. All right? Now, what do I set this equal to?
0.
Can this ever equal 0?
No.
So the only time it's 0 is what? When x is 0. Correct?
Correct.
So I believe on 14 you're negative infinity to infinity. So all you need to find is f of 0.
Will it not be like a minimum or max, I guess?
Well, it's going to be one or the other.
Wait. What?
How do we find that equals 0?
You plug 0 in for x, right?
In the original.
But it's in the O.
Yeah. So you do that. Oh, wait a minute. Hold on.
That's how we found y all year, is plugging it in the original. Okay. The only way to know if it's a minimum or maximum is you can pick a number on each side. Like I could pick negative 1 and put it in, and 1 and put it in, and you would be able to tell if it's doing what it's doing.
You get one.
Or you can graph it.
I got one.
Miss Thompson,
Confirm 1.
on this one's actually number 12, but when I graphed this one, it looks like I have it.
You know, it's all like minimum and
So
maximum.
that
Well,
means
the maximum is 1
1.
on 12.
Well, you're only looking from negative 1 to 1.
It's from negative infinity to negative 1.
That's why it has a min and max.
Not
1 to infinity.
Okay.
Does that make sense? Okay, Corbin, what?
Okay, so how do we, so is this just how you want us to write our answers?
No, I want to know, is that a min or max?
How do you find that?
Okay, so,
Okay, you guys know what? If you'd have been listening, you would have heard how I said, because I told two ways. And guess what? You know either one of them?
Well, I didn't know if you were talking to, I thought you were just talking to them, because you weren't addressing the whole class.
Okay, every time I'm talking, I'm addressing the whole class unless I say otherwise. How's that?
Okay, now we're clear.
All right. Now, I don't know. What did you get for f of 0, by the way?
1.
1. You're telling me you don't know if that's a min or max.
I think it's max.
My choices are, I can pick numbers on each side of 0, which could pick -1, or I could pick add 1. I have to do both sides. And plot those points, and I can figure out if it was a min or max. Your other choice is to graph the original function and look at it. It cannot be both. Where are we going next? 16?
Yep.
Really?
Yep.
Yes. Yeah.
What's the derivative of 16?
1.
secant x.
No. What's the derivative of 16?
Secant x and x.
I went far. I did the thing we did last.
Oh, the 1 over.
So I set this equal to 0. You did inverses. What?
That's really frustrating.
And let me tell you, if you don't remember, secant x never equals 0. Because is it secant cosine turned over? Right? So when is tan x equal to 0? Do you know?
At pi over 2.
When sine is 0?
When sine is 0. Very good.
0.
So,
Pi over 2.
When is sine 0?
pi over 0.
Where else?
Pi.
So x equals 0 at 0 and pi.
And 2 pi?
2 pi is not in my interval.
Yeah.
So now I have to do f of negative pi over 2, f of 0, f of pi, and f of 3 pi over 2. Right? And decide if each one is a min or max. Yes.
Oh, error.
What's secant 1 divided by cosine?
Error. Oh my good.
Where are we going next? No, we got to move on. I've still got to teach today's lesson.
I got a 0. I got an error. How do you not get an error?
Maybe put a whole parentheses.
Make sure you're in radian though.
Ooh, good call.
Oh, no. I got
On
Yeah,
what?
I still got an error.
Negative
I
1.
got an error when I put it.
I didn't get an error and I was in degree mode.
And maybe you're in degree mode.
No, I got an error. I'm just saying.
Oh, you got an error too.
Where'd you get an error?
On 1 over cosine negative 2.
What?
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 Hold on.
On negative pi over 2 through pi over 2 is errors, but that's
Yeah,
just,
that's what I got.
that's secant.
I
That is because pi over 2 is undefined. That's where an asymptote
That's
is.
one negative.
So this one doesn't have an answer, does it?
not gotten a single error. Or have I did wrong?
You're probably agreeing.
Remember, with Mr. A, when you agree, you have to change it over. I didn't even.
And I want them back, okay?
It's one over the next one.
Yeah. So this would be a local, then negative. I think equals zero, and there would be no.
That's a max.
So that should not be one.
Oh, to that,
I
so,
don't know if that's.
Isn't it? Does it go up and then down?
yeah.
Because for that piece of the graph, it's a max.
So,
There's no min.
well, would we have to do like two separate local, like a min and a max?
I don't think there's a min. 40? Right?
Yes.
What does it look like?
Got.
I think it looks like this.
Yeah.
That's what I think 40 looks like. You agree? A critical point could be 0. Because that's where I change from one piece to the other. So that's a possible critical point.
For critical points, do we just put the X value or do we have to put like a ordered pair?
Critical point. Point means X and Y.
Okay, so if I stated the min and maxes, does that cover it? Or do you have to also do?
That's okay. So at X equals 0, f of 0, is it 3?
Yeah.
Is that a min or max? Min. Min, isn't it? It's also a critical point when the derivative equals 0, isn't it? The derivative of the first piece, does it ever equal 0? What about the second piece? What's the derivative of the second piece? No, it is not. It's 2 minus 2x equals 0. So is x equal 1 a critical point?
Yep.
So what is f of 1? 4?
Yep.
Min or max? Max.
Wait, so you found if it was a min or a max?
Guess what this is? Mean value theorem. When I talk about mean value, what does that mean?
Average.
Average. The mean value theorem says, real close to the extreme value that we did yesterday, if I have a closed interval, that somewhere in this interval, and I'm going to tell you this mean value theorem, I can read it to you on that page. If x is continuous at every point on the closed interval and differential at every point of its exterior, there's at least one point C in AB at which f prime of C equals f of B minus f of A over B minus A. Does that make total sense?
Yep.
What you need to know about the mean value theorem, you need to know this.
Oh, yes. Yes.
That's the mean value theorem. What it says is, I'll let you write that down, and then I'll tell you. What the mean value theorem says is, if I'm given a function that is between these 2 points, between A and B, I could find the slope of this line, couldn't I? That's what this formula is. the slope of the line. Somewhere in here, the derivative, the tangent to this derivative will have that same slope. That's all that means. And for this one, isn't it about right here?
Oh, yeah.
And what you're going to find is the x value where that happens.
It's supposed to be like a little slanted line.
Slanted.
So are they parallel?
So they should be parallel. Somewhere in there, they'll have the same slope when being parallel.
And that formula
That's what the mean value theorem means. Now, knowing that, can we work one?
I'm sure so.
Now remember, it has to be continuous, it has to be closed, and it has to be differentiable. When can I not take a derivative?
Whenever it's a cusp.
When it's a cusp or a corner or
Or
not continuous, right? All right, so, I don't want to start with a hard one right off the bat, do I?
no.
If f of x equals x squared plus 2x minus 1. From 0 to 1. If I graph x squared plus 2x minus 1, what is that? What is that? It's a parabola. Is it on a closed interval?
Yeah.
Is it continuous?
Yes.
Yes, a parabola is continuous, isn't it? Does it have a corner or a cusp?
No.
So it must be differentiable. So what I want to know is, first thing I want to know is this, which is, this is the slope between 0 and 1.
Okay.
That's what I want to find first. Find it.
What's B?
What's that?
Yeah. What's that?
The interval is A to B,
Oh,
Okay. Okay.
just like it was yesterday.
Was it like that yesterday?
Okay.
I didn't know that.
I got 3.
Wait,
I would like somebody to agree or disagree.
I got 3.
You got 3?
I'm so, I have written down nothing. Okay. Yeah. Oops.
Well, we're moving on.
let's go through.
This is 3 has to equal f prime of c, according to our mean value theorem, correct? Now, what I want to know is, I want to find f, I want to find c.
3. No.
That means I take the derivative of my function,
Set it equal to 3.
set it equal to 3, set it equal to my slope.
The original function.
The original function, the derivative of it.
I got 3.
So 3 equals
3.
2x plus 2, correct? So what is x? X equals 1/2. So what I have found, if I were to graph this function at x equals 1/2, it has the same slope as between those 2 points. So my question is, first of all, did the mean value theorem apply? Yes, because it was continuous, it was closed, and if it was differentiable. Now, what is C?
C.
1/2. That's my second answer. Does that make sense to you?
Okay, yeah.
Okay. What about this one? My first question is, does the mean value theorem apply?
On absolute values, because
No, why?
It has
Has a corner. Has a corner, doesn't it? So, the first question was, does the mean value theorem apply? No, there is a corner.
Yeah.
And I'm through. I don't find it since it doesn't happen. Okay? Now let's go to a harder one. F of x equals inverse sine of x. F of x equals inverse sine of x from -1 to 1. Does it apply?
it looks like it does.
Let's say, I'm going to tell you it does.
Okay.
Because on the sine graph, doesn't it exist from -1 to 1? That's all it's asking. And it doesn't have a corner in there, or a vertical tangent, or anything. So now what do I want to do? Okay, I want to do this. F of b minus f of a over b minus a equals f prime of c, right? Think about the sine graph. Think about the sine graph. Oh, we have to have an interval. I'm sorry. That's my bad. I didn't give you the interval. You can't do that.
-1, 1.
Oh, okay. All right. Just making sure. So, doesn't the sine graph look like this? It's a 0. Does it? So, f of b is, when is sine 1? Pi over 2. So I have pi over 2 minus 3 pi over 2, right? Over
That doesn't look like it would be 5.
Why?
Wait, wouldn't it just...
Wait a minute. Actually on inverse sine, don't we look from here to here?
Yeah.
I didn't know that.
Yes, you did. You might have forgotten, but you did know it. So where does this happen? Plus pi over 2.
Wait.
Huh? Okay, I don't understand that part.
I don't understand how that makes.
When we did inverse sine, we did quadrant 1 for quadrant 4. We did from here to here. It's the only place we looked at.
Okay.
All right? So we're here. What is b minus a?
Oh,
One.
sorry.
Two.
2.
Come on, guys. So, do I get has to equal, what is the inverse sine? Derivative.
Oh, 1 over rather 1 minus u squared. Times 1.
1 minus
X squared.
What?
Okay, so can we make it, x squared minus x?
No, it's times the derivative of x, which is 1. Right? So does pi radical 1 minus x squared equal 2?
Oh, it's an equal sign, that makes more sense, okay.
Right?
Wait, isn't pi over 2 pi over 2? Hold on.
I think,
That would be pi.
I think we already said this, but why don't we multiply by 2?
I cross multiply.
Oh,
I cross multiply.
But when you take the derivative, don't you have to?
The derivative of this isn't you just x?
Oh, okay, so you take the derivative of the original.
Yes, ma'am. I'm going to finish this really quick because we're running out of time. So what the square root of 1 minus x squared is 2 over pi. Square both sides. 1 minus x squared is 4 over pi squared.
Yeah.
So does x squared equal 1 minus 4 over pi squared?
That over a radical, you got it? Oh, plus or minus though. Why can't we just try to find x?
We're just trying to find x. What'd you get?
Oh. No,
771.
0.771.
is it plus or minus? It's the square.
You just have to find one value.
Okay.
And that's C, okay?
I got 0.77.
Yes. I think Renweb is wrong on this one. I'll get it fixed. 2 through 38 even. You cannot do all of them. I didn't get that far.